All right, let's dig into another application of proportions, and this one is the Consumer Price Index. So, inflation, I know that you've all heard of inflation. So, inflation is when, general goods and services increase in price. So, think, gasoline is a good one that you can kind of think of. Bacon, the price of bacon over the last couple of years has just skyrocketed, those kind of things. So, inflation is just in general the rise of prices and things. The Consumer Price Index is how we list this. So we have a monthly number. Basically, think of it this way. Somebody goes out and they buy like a pound of bacon, a gallon of gas, a quart of oil, a dozen eggs, a box of tampons, a new t-shirt, and a coffee from Starbucks, right? I'm making this up, but just for the idea. And every month, the person goes out to the same spots and buys the same stuff every month. And then they compare. And how it goes up or down, that's how they base the Consumer Price Index. So they get this general idea of how goods and services are being priced. And of course, it's not just 7 things, it's probably 75 or maybe 400 things. I honestly don't know. But that's the basic idea. And then they compare it month to month to get an idea of how the inflation is going. So you see over here on the right, this is our basic table that we're going to go. So this is our CPI values for each year, the average for the year. And so you can see in 1978, the value of this basket was $65.20. And in 1993, it had risen to $144.50. And in 2016, it was $240, in a penny, round to the nearest cent. So obviously, things are continuing to get more expensive. I don't think anybody disagrees with that. But how can we use this table to do math? Well, we can use it to play the what-if game. So you can see here, in 1979, a McDonald's hamburger cost 79 cents, 38 cents. Sorry, looking at the wrong problem on my paper, 38 cents. What does that equate to in 2015 dollars? So here's the deal. I set up every CPI problem, and you know that you're going to have a CPI problem if you're comparing money over time. So I have 2 years. I have 1979 in 2015. I'm comparing money, and to compare this over time, I need a CPI value. So these are kind of the labels for my proportion. Okay, so think about this. In 1979, the hamburger was 38 cents. And in 1979, we come down here, the CPI value was 72.6. The zeros after a decimal point, right, mean nothing. Then we go to 2015. I don't know what the price of the hamburger would be if it just rose with inflation. But I've got a CPI value of 237.017. Now I can cross multiply and solve, and we would say if a hamburger was 38 cents in 1979, then that hamburger should be $1.24 in 2015. And I'll be honest, I don't go to McDonald's. It hurts my stomach, except for the French fries, but you can't live on that, at least not well. But I think the hamburger is still on the dollar menu. So I guess the current price is probably $1.07 if you use tax. I think that's a question mark, but it's pretty comparable, maybe off by 17 cents or so, but not too bad. Let's go to the next one. According to the NCES, the starting annual salary for a college graduate in 1983 was $25,000. What would that be in 2013 if it kept up with inflation? So now we're comparing 1983 to 2013. And again, we're going to compare money to CPI. Okay, so 1983, we're talking $25,000. And we're talking 99.6, right? You can see how I circled it down here. In 2013, we're trying to find the money, and the CPI for 2013, 232,957. Again, we cross multiply, and we end up with a value of 58,473.14 cents. So in 30 years, you can see that the salary has more than doubled, which makes sense because the CPI value has more than doubled. Okay, now if we look at Part B, we are going to compare the 1983 to 1977. So I still have 1983, and now I'm comparing to 1977, again, money over CPI. So I still have 25,000 over 99 and 6/10. And then 1977 is way down here at the bottom, which is 60.6. So obviously you can see the CPIs are less. So when you cross multiply and divide, for 1977, you would have a starting salary of $15,210.84. So very different, all right, depending on which way you're going. But that's the basic setup of using CPI. All right, so let's look at the next problem. Suppose a 20-ounce soda cost 25 cents in 1977. What does that cost in 2015? Okay, well, we've got 1977, 2015. So 1977, the cost was 25 cents. CPI, again, is way at the bottom, 60.6. 2015, we're trying to find that, but the CPI is 237.017. I cross multiply, and a 20-ounce soda in 2015 should cost 98 cents. Now, I understand we're not in 2015 anymore, but if you think about this, last time I bought a 20-ounce soda at either a grocery store or at a gas station, it's like $1.49, $1.69, $1.89, depending on what brand you buy. I guess if you're buying Faygo, you can buy a Faygo for 99 cents at the Meijer gas station close to me. But if you're going to buy a Pepsi or a Coke product, or even a 7-Up product, I think they're even more than 99 cents now. So anyway, so how does this compare? Oh, that's what we just talked about. So I'm going to say the average price of a soda right now is $1.50. That's what I'm just going to throw out. Therefore, this has increased faster than inflation, because with inflation, pop should just be 98 cents for that bottle, but it's really closer to $1.50. So the price has surpassed inflation and gotten higher. I hope that makes sense. So it's gone definitely faster than inflation. Now, just real quick, maybe if you buy the 20-ounce sodas in a 6-pack, like at Meijer or Walmart or something in the grocery store, that might be different. But if you're just buying a 20-ounce soda at the gas station, it grew faster than inflation. Okay, let's do some federal debt per capita problems real quick here. We know what federal debt per capita is, so we can see the federal debt was this huge number, right, over $5 trillion with a population of 281 million. So find the federal debt per capita. Okay, now one thing that I want to shove out is that you guys know that million means times 10 to the 6th. So if I just say, okay, look at, there's 6 decimal places. So this is 5,674,178 times 10 to the 6th. That's what these 6 zeros are. And I know that 281 million is 281 times 10 to the 6th. And you might say, Becky, that doesn't make any, I don't know why you did that. Well, since these match, they just cancel out. And now I can just divide 5,674,178 divided by 281, which leaves me with 25,500, oh, wrong button. That is the wrong problem. Back up. $20,192.80. So in the year 2000, that is the federal debt per capita. And so that was the overall debt, which if you think about it, that's a lot per person. I'm not giving up $20,000 to help the federal debt, right? That's crazy. So now we're going to estimate what would that be in 2010 if we adjust for inflation. So we're now comparing 2000 to 2010. Well, we just found that in 2000, the federal debt was $20,192.80, right? Is that the right number? Yes. Okay, 2000, here's my CPI, 172.2. What would that be in 2010? Well, here's my CPI, 218.056. We cross multiply, we divide, and we would get $25,570.04. Now, again, remember, this is per person. So if the federal debt per capita increased with inflation, by 2010, everybody would owe a little over $25,000. Well, let's look at the actuality of that. The federal debt had grown to be over 13 trillion, and the population grew to 309 million. So what would that be? So this is in 2010. Again, I'm going to cut off these last 6 and do my 13, 561, 623 times 10 to the 6th. That way I can divide by 309 times 10 to the 6th, and I can have these guys cancel out. So when I just divide, I end up with $43,888.75. So compare these values. Okay, for comparison, remember the last one I said with inflation, it should have been 25,570 and 4 cents. It really is almost $44,000. This is what it should be. This is what it actually is. That's a crazy difference. The federal debt per capita grew, oh, that's the next question. I lied, I don't have a C on here. It grew, it's right here. Oh my gosh, wake up, Becky. So the federal debt per capita grew a lot faster than inflation, just crazy amount faster than inflation. Okay, now we can move on to the next question. Minimum wage, and this should say 2017, still $7.25, like it or not, that's what it is. So what is the current minimum wage? $7.25. We're going to use 2000 data as current because that's what we have. So what is the ratio of current to that of 1980? So current is 2017. We can't use 1980. It's no longer on our table. So we're going to use 1979. All right, so then we're going to use 1979. So 725 compared to 2. Now, if you divide those, you get 3.625, which means minimum wage is 3.625 times higher now than it was in 1979, which makes sense. You can kind of see that. If you took what it was in 1979 and you multiplied by 3.625, you would get the current minimum wage of 7.25, which is why I said that. Okay, math problem. Determine whether minimum wage has kept up with inflation since 1979. Okay, so this is a what-if game. This is comparing 1979 to now, which we're going to use 2017. And again, we're talking CPI, so money in CPI. We know that minimum wage was $2 in 1979. And I understand that we know what it was in 2017, but we're trying to see, this value here is talking about what it should be right now. Based off of the CPI values and what it was in 1979, what should it be now? So, okay, 1979 has a 72.6, and then I go to 2017, and I get 240, oops, I forgot my 4, 245.12. Pause. Okay, sorry about that, I had an email. Okay, so we're trying to find what it should be for this. So if we cross multiply, we find an X value of $6.75. So this is what the minimum wage should be if it kept up with inflation from 1979. Now we know the actual, get off of there, the actual value is $7.25. So by this one calculation, this shows that the minimum wage has actually, get off of there, has actually grown faster than inflation. Because it should only be $6.75, but it's actually $7.25. And so, and you can argue this, whatever, if we had picked a different year besides 1979, it's very possible that it would have come up that it grew slower than inflation. And that's where you can use math to kind of argue the same, both sides of the same point, depending on which proportion you use. So this just happened to be that the actual is higher than the should be, and so we can say it grows faster. It's just one way to argue math. So, yeah, there you go.